Okay, so what we're finishing up with chapter 1.1 is going to be intervals, bounded and unbounded, and interval notation is what we're going to finish up with. Now, there's two main types of intervals. We're going to talk about bounded and unbounded. Bounded means that it has two endpoints. You covered this probably in Algebra 1, yes? Bounded has two endpoints. There's a start and a finish. Unbounded means we either have a start point and it goes on forever in one direction or the other, or it could just go on forever in both directions. It is unbounded. It does not end in one direction. We talked about these unbounded ones in geometry, but we didn't call them unbounded. We called them rays, because a ray is a line that has an endpoint and continues on indefinitely in a direction. But here it's only going to go one way. It's either going to go to the right, or it's going to go to the left, or it'll go both. Any questions on these so far? Hopefully mostly review. Now hopefully this printed well, because I think some of it printed pretty small for your notes, is this here. Let A and B be two real numbers such that A is less than B, then A and B are endpoints of four different bounded intervals on the real number line. This here is really just math jargon for we're defining anything, any type of situation where this will work. A and B are two numbers. It doesn't matter what numbers. We're just stating that A is always less than B. So if we said A was 2, B could be, what, Eric? 4. It doesn't matter which. It's just that B has to be greater than whatever A is. And that's all we're saying. They're always going to be in that set. Okay? Now, the first type of inequality we could have with this is something like this here. A is less than or equal to X is less than or equal to B. So we're saying that whatever A and B are, our numbers are between them. And our notation for this, if we're going to write it, we have it A, comma B with brackets, because brackets means equals. Brackets means equals, and we'll see that parentheses means not equals. And this here is an example of what this would look on a number line. Now our next one is almost the same thing, but they are not equal. It's A is less than X is less than B. So the numbers we're looking at are between A and B, but they are not equal to A or B. So this will look very similar to the first one on the number line, except instead of having closed squares I have on here, or closed circles filled in, they're open. And the open circles here tells me that A and B are not included. We have all the way up to A and all the way up to B, but we don't have whatever the values of A and B are. So if A and B were 2 and 4, it would include all the numbers all the way up to A, so all the way up to 2, so anything just slightly bigger than 2 would be included, and anything slightly smaller than B or slightly smaller than 4 would work. So if we considered the number, so I'll write this down, so we're not just thinking of the number. So if we said 2 and 4, so would 2.0001 be included in this? Yes, anything bigger than 2. Even if it's insignificantly bigger, it still would count. Probably this is mostly review for y'all, yes? Hopefully. Okay. Now, we also have two other cases, and I'll go on and show you both of these here. And our other two cases is in considering that one side or the other is included. So the first one, we say A is less than or equal to X is less than B. So as we said in our example, that would be 2. We said A was 2. So 2 would be included, but 4 would not. And the one below it, we're saying B is included, but A is not. And this right here is pretty much every way we can do these here with bounded, meaning it has two endpoints. These are the four ways we can have it set up. Either both points are included, neither point's included, the one on the right is included but not the left, or not the right but the left is. So this is the four ways we can have a bounded interval set up. It's in one of these four. Now, unbounded intervals. There are four main types of unbounded intervals. Now, with unbounded, we don't have an A and B because there's only one real endpoint in an unbounded interval. So let A be a real number. So let A be real numbers. Each interval on the real number line shown below is called unbounded. Now, the first one we can have is that X, or whatever the number is greater than or equal to A. Now, our notation for this is parentheses A comma infinity. So since it is equal to, we will use a bracket for A, but we will use a parentheses for infinity. Because again, brackets mean it's included, parentheses means it's not. Now, why would I not use a bracket for infinity? Because it can't be contained. Yeah, and one of the big things with infinity is we can never reach it. So it might be a little hard to imagine, but think of a huge number. Biggest number you could possibly think of. Well, then we can add 1 to it, can't we? No matter how big a number we could ever get to, we can always add 1 more, yes? So no matter what number we ever hit, we can always have 1 more. And one of the big postulations they've done with this is they called it the infinity hotel. All right? Because thinking of a number like infinity is hard to imagine, yes? Imagine a hotel that has infinite number of rooms. Infinite number of rooms. Huge hotel, yes? And you're the desk clerk, and every room in that hotel is filled. And you as the desk clerk want to try to satisfy everybody. You're trying to make people happy. And someone comes in wanting a room. Well, you're not wanting to displease them. You want to put them in a room. But in your infinite number of rooms, every room is full. So you come up with an idea. I have an idea. I will tell the person in room 1 to move to room 2. Person in room 2 moves to 3, 3 to 4, 4 to 5, 5 to 6, going all the way down. There's an infinite number of rooms. And what did we just do? We just made room number 1 is now open, isn't it? So the new guest can now move into room 1. We just took infinity and made it 1 bigger, didn't we? That's one of the reasons that we can do that. And it's even, we can get even more expansive because I can move infinity into infinity. Because if you told the person in room 1 to move to room 2, person in room 2 to move to room 4, 3 to 6, move to every even number. Now that makes all the odd numbers open, yes? So I have an infinite number of odd rooms that are now open. So I can move an infinity into the infinity hotel. So again, infinity, we can never really reach it. And that's why they have that open parenthesis, because it's a number we can't get to, just like Stone said. So we always use a parenthesis whenever we talk about infinity in interval notation. Now we also have A is just, X is greater than A. So A is not included. So on this one here, because a is not included, there's not an equal sign in our inequality, we use a parenthesis. And the last two here, we have x is less than or equal to a, unless x is less than a. So it's almost the same thing, but now we're going towards negative infinity, not positive infinity. And whenever we do these interval notation, the bigger number will be on the right, the smaller number will be on the left. How many of y'all have a hard time drawing the infinity sign? Yes? Yes? Turn your paper sideways and draw an 8. Does the exact same thing. It's just an 8 that fell over. And for those of you who are wondering, you're saying there's one more here in the boxes. I put that up there because that's technically our all real situation. Every number on the number line's included. Because if we have something called a compound inequality, where we have two unbounded intervals being combined. So if we said that we took this one, the top one, x is less or greater than or equal to a, and x is less than or equal to a, and combine those, well, we'd have the whole number line because everything would be included. Any questions on these here? We good with these here? Now the next one I realized printed really, really small, yes? I don't know why it did that, but it did that, so I'm going to try to fix that on the next one. Make sure they all printed a decent size. Now, what we're going to do is we're going to write each interval in interval notation. So our interval notation is our parentheses and brackets, using those to write whatever's defined here. So normally, as long as we have these kind of basic, what I'll call basic intervals, we're going to have two numbers. So what are our two numbers for A going to be? Well, we would have -2 and 3. Because here, we're talking about the numbers on the interval from -2 to 3. Because it's saying our numbers start at -2 and they end at 3. Now, will I use parentheses or brackets? On both? We use brackets on both because since it says equals, that means we need brackets on both. Whenever we have equals, we will always use brackets. Any questions on the first one? So let's look at the second one. Well, what is my other number for the second one? Because I see there's a -1. But what's the other one going to be? Because it doesn't tell us. Infinity. Would it be positive or negative? Positive, because we're talking about x being greater than -1. So we want all the numbers greater than it. So we would have positive infinity. Would we put the -1 on the left or the right? Be the left of negative infinity or to the right of negative infinity? Because what's bigger, -1 or infinity? So infinity, so it would be on the right, and -1 would be on the left, because the bigger number is always going to be on the right, the smaller number will be on the left. Now, is -1 included? No, so we would use a parentheses, and here we would use a parentheses. So this here is the interval notation for x is greater than -1. So if it's bounded, we will have two numbers. If it's unbounded, we'll have a number and an infinity, either positive or negative. So looking at this next one, are we bounded or unbounded? Bounded. So what are our two numbers? -3 would be on the left, 4 would be on the right. Oh, you're good. You're good. So -3 comma 4. So what would be our parentheses or brackets on this? So bracket -3 comma 4 parentheses. Any questions on any of what you've done so far? Give you a few seconds. See if you can write down what the interval notation for this one's going to be. Anybody want to say what they got for this one? Yes. And we would have? That's it. Any questions on any of these here? So we good with these here? Yes? Awesome. Set builder notation. Okay, this is another year in a row. I've meant to move this slide farther forward in this lesson, because we've covered this a little bit yesterday. I really wish this was farther forward. Set builder notation uses symbols to define a set in terms of the properties of the members of the set. Now you guys have all of that down there. And we've seen this yesterday, yes? So the way we read this, and kind of I went over it a little bit, is the set of all real numbers x. So the set of all real numbers x is, let me get a highlighter. Is everything right there. So that parentheses in x, in mathematical terms, is the set of all real numbers x, such that. That's just that bar. That bar means such that x is less than b. Is all of this right here. So in mathematics, instead of writing out the set of all real numbers x such that x is less than b, we write it like this here. So we can also deal with compound inequalities, such as this here. So for the set of all real numbers x such that x is less than or equal to a, or x is greater than b. So we talk about two unbounded inequalities, like this here. Or we can use it like we did the other day, where we did not include, I think it was the number 4. I used a different number for the other hour. Like x, for all real numbers x, x is not equal to a, whatever a is. So it's every number on the number line, excluding that one. Excluding that one number. Any questions on either one of these here? Okay, that's fine. Okay, we good here? So we're going to sketch the graph of each of these here. So it says the set of all real numbers x such that 2 is less than x is less than or equal to 5. Now for this here, because x is in the middle, it means we have a bounded set because x is going to be between those two values. Yes? So what are our two values? We have 2 and 5. Now 5 will be included because it says it's equal to, so we fill 5 in. And then what do? We shade in the middle, shade between them. Now on the homework assignment, it will give you options down below the graph when you graph this. And it'll tell you bounded or well, essentially we'll have for bounded, it should have 2 circles, open, close, one open, one closed, however it may be. And then it'll also have unbounded, so an open or closed circle pointing in one direction or the other. What you've got to do with that is pick the correct one. So pick one that has one open, one closed, and click the numbers, and it'll put it on there. Okay? Does that make sense? We can go over it when we get to it. Now, letter B is a little bit different than what we've done up to this point, because it says that x, for all real numbers x, such that x is less than or equal to 0 or x is greater than 4. Is this a bounded set? Okay, so x is less than 0, so is negative 2 less than 0? Is negative 2 greater than 4? So, okay, well, 5 is greater than 4, yes? Is 5 less than 0? No, 5 isn't less than 0, is it? So what this is 2 unbounded sets going in opposite directions. Does that make sense? So let's just look at this one here. X is less than or equal to 0. So at 0, what would we have? Open or closed? And which way do I shade? Because it's everything less than 0, yes? Now here we have x is greater than 4. So at 4 we have an open circle and we shade to the and that's it. Now in OR statement we include both because OR, unless we have a, or I lost the name of it, there's a specific type of OR case. I think it's exclusive OR, where it only has to be one or the other. But whenever we talk about OR, it's one or the other. One or the other. It could be both, as long as one of them's true. Because as we said, negative 1 makes this statement true. Yes, negative 1 is less than 0 or equal. So it works. 5 works because it is greater than 4. As long as one of them works, we're good. We'll talk about and eventually, and that one has to include both. Let's look at letter C. Sketch the graph of these sets of numbers. So the set of all real numbers x such that x is less than negative 2 or x is greater than 0. I want y'all to give this one a try on your paper. Give this one a try and then we'll do it together. It's hard to see those numbers. All right, so let's look at this here. So since it's an OR statement, we're going to include both. OR statements, we can just put everything on the graph, really. So let's start off with the first statement. X is less than negative 2. So at negative 2, we have an open or closed. And we shade to the right or to the left, because that's all the numbers less than negative 2. And you can always check it to make sure by just picking a number. Since I shaded to the left, so we look at negative 3. Is negative 3 less than negative 2? So we shaded the right way. Now let's look at the other one. X is greater than 0. So at 0, we would put in open circle, yes, a circle, and we would shade to the. So then I can check it by picking a number. So 3. Is 3 greater than 0? So it works. So let's look at negative 1. Is negative 1 less than negative 2? No. Is negative 1 greater than 0? So it doesn't work. So a lot of the times, if you want to make sure, we can always go back and check. Are there any other questions on how to sketch these here? Are we good with sketching these? Yes? Do y'all need to see another example of sketching these? No? We're good? Okay. This is the last thing we're going to do today, is writing these in set builder. Write the set of all numbers, the set of all real numbers. So the set of all real integers greater than 5. So this is using those parentheses. So we would have what? Parentheses. X is an element of the integer. So for this is referring back to yesterday, we use Z. Now the reason we have to use this is because, well, if you think back to a few minutes ago, our basic set builder, which was just this here, said what? The set of all real numbers. Are we talking about real numbers here? We're talking about integers, so we have to change it. So the set of all real integers such that what? X is greater than 5. That's it. I believe the textbook will use X is an integer such that X is. That's possibly how the textbook's going to do it. So I will double check and look and see when they put these in your answers to see how they line up. Any questions on this here? Last one here. So we're talking about all real numbers, yes? Because they didn't tell us otherwise. On a number line, especially with interval notation, we're talking about all real numbers. So that's kind of handy because our first thing we're going to do is just bracket X bar. The set of all real numbers X such that. What would we write for this here? Well, we're going from negative infinity to negative 1, yes? And what's this one doing? So I could do, well, this here is really everything less than negative 1, yes? So we can say what? X is, or, but that's what those two statements are saying, aren't they? Negative 1 to, or negative infinity to negative 1 in parentheses is really saying all the numbers less than negative 1. The other one is saying negative 1 comma infinity is all the numbers greater than negative 1. So what are we not including? Negative 1, right? So wouldn't this be the same as saying X such that X is not equal to negative 1. That's the same thing. Because that's all it's saying. It's saying every number except negative 1. I don't know how mathematically inclined this is, or notation, but I believe we could probably do this here, negative parentheses, negative infinity, comma infinity. What is that? Apostrophe negative 1 in brackets. Because we use that kind of apostrophe kind of deal, as to say excluding. It's included in this, excludes this. Mathematically, it'll show it more like, so it's the set of all real numbers excluding negative 2. So we can exclude some sets. But again, this does not come up in algebra, calculus. It normally comes up after calculus when you talk about high-level proofs. Any questions on these here? Do you guys want to look at either one of these here? Huh? This one? Okay. So let's look at this one here. So I look at this one here. So set builder notation means we're going to do what? Bracket x bar. The set of all real numbers, because again, we're talking about intervals. Intervals will always be the set of all real numbers. Okay, such that what? So x would be less than or equal to, so less than or equal to, because we do have a bracket, or, because this here is saying negative 1, it includes negative 1, and everything smaller than it. And our other one is saying what? Everything greater than 1, yes? So this would be x is greater than 1. Any questions on this here? We good with this here? Yes? Now this one here will be similar to one we did previous. Because we'll have to say x is an element of the integers, or x is an integer, such that what? X is not equal to negative 4. Because it excludes negative 4, except negative 4. It's not included. Any questions on this here? Any questions on anything we went over today? We good with this here? Yes? For the most part? If you have questions, ask. Because I believe that is it. Now, I already released the assignment